Okay, so here's one of the word problems. I'm not sure exactly which one you want me to work out. And there's a lawnmower outside if you hear that, so FYI. So in this one, we're given an equation, and again, it's a very ugly quadratic. But you see, this is your ax squared plus bx plus c. So it asks you to use the graph to estimate what the most economical airspeed is. Well, the x values here represent the airspeed, and we want to know the one that'll save the most fuel. So you're going to look for the vertex, the highest point. So we can see that vertex is happening somewhere around in here. And again, you got the A part right, it looks like, where you estimated it to be around 100. So that's just a good rough estimate. We can see it's actually a little bit less than 100, but it's hard to tell exactly what it is just from the graph. So the graph just gives us an estimate. Now B part, to figure out what is it that actually maximizes the mileage M, we would use our axis of symmetry formula to help us find the vertex. So we know the vertex is somewhere here. And to figure out where that is, we're going to plug into x equals negative b over 2a. So for this problem, that's going to be negative 0.126 over 2 times a, which is negative 0.000655. You have to give me a second. Let me plug those in to my calculator. When I did that, I got x was equal to 96.183. And it tells me to round to 2 decimal places. So the 3 would tell the 8 to stay the same. So it tells me the x value is at 96.18, which is about what I expected. I said that it looks like it's a little bit less than 100. Well, it turns out it's exactly 96.18, so that kind of agrees with my original thought. So that would be B part. Okay, C part can be a little bit confusing. Let me just write down all of my units. So I have 96 miles per hour. Then I have 1 mile per pound. And then I have 6.17 pounds per gallon. And so I find the best way to do this problem is to be looking at what my final answer units should be in. So they want my answer to be in gallons per hour. So I can see if I multiply these two, that my pounds will cancel out, and that's going to give me 6.17 miles for every gallon of fuel. And now if they're going 96 miles per hour, then what we're going to do then is divide. If they can go 96 miles in an hour and they get 6.17 miles per every gallon, when I divide that, that's going to give me how many gallons per hour they are burning. So I would do 96 divided by 6.17. And that tells me that it is 15.559 miles per every gallon. And I would need to round that to the nearest tenth. So it says 2 decimal places. So the 9 would tell the 5 to go up to 15.56. Okay, so here's another one that it's another word problem. So it looks like you've got A part correct. So I'll skip over that one for right now. B part, it wants to know what is the shot's maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw. So the horizontal distance is the distance along the x-axis. So the farthest point that the shot is thrown would be whatever happens when the x value is, whatever the x value is when my y value is 0. So what I'm essentially looking for is the x-intercept. So if I'm looking for x-intercepts, I can plug into the quadratic formula. So I would take this equation, plug it into the quadratic formula to find that x-intercept. Now I'm going to find two x-intercepts. The other x-intercept will happen over here where my x value is negative. But again, that would not make sense. I'm only looking for the red dot. So if I get a negative x-intercept, I know I can disregard that one. So plugging in, I'm going to get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so I'm going to have to plug that into my calculator. So when I plug that in, I got x was equal to 77.4852. And it tells me to round to the nearest tenth, so I'm going to 1 decimal place. So the 8 tells the 4 to round up. So I would get x equals 77.5. It looks like you were close. You had 77.45. So I'm not sure how you get the 4.5. If you had 4.8 or 4.9, I could say that you just didn't round it. But you might want to check your calculations there. And then C part wants to know what height was the shot released. So you got to think about it. This is the shot put traveling along the x-axis, and this was its flight. So the height it was released at would be whatever it was when its distance was at 0. So that would be right here, the y-intercept. And so I can tell the y-intercept of my quadratic is always this constant at the end. So again, if I plug in 0 for x, this term is going to cancel and this term is going to cancel, leaving me with 5.8. So my y-intercept would be 5.8. And that would be the answer to the last one, the height it was released. And so these box problems are tricky. So let's look at this one. It says an open box is made from a 30 by 40 centimeter piece of tin by cutting a square from each corner and folding up the edges. The area of the resulting base is 336 square centimeters. What is the length of the sides of the square? So you can see that they have cut the corners, folded it up, and this is what they have. So they're telling me that the base here is 336 square centimeters. Well, I can find the base of the original because it's just a rectangle that's a 30 by 40. So if I multiply 30 by 40, that's going to give me 1,200 centimeters for that one. So what we're basically wanting to know is, well, what did we cut? Because we cut them in squares. So I need to know what was the length and the width of the new base compared to the old one. Okay, so what we're basically looking for, first off, is how much did we cut out? Well, we don't know, but we know that every distance that was cut out was the same. So we can call it x. Okay, so again, we don't know how much we cut out of the corner, but we know that every one of these values is going to be x, and x, and x. So if you think about it, once I cut those x's out, what is the length going to be? Well, it used to be 40 total, but then I'm going to cut out an x here, and I'm going to cut out an x here. So the length is going to be 40 minus x minus x. So that's going to be 40 minus 2x. Now, similarly, when we're finding the width, Same idea. We cut out 2 x's from the width that used to be 30. So the width used to be 30, but I've lost 2 x's on both sides. And so this area and width would be how we would get the area of our new base, which we know is 336, after we've cut those corners out. So we can set up a formula that says area is equal to length times width. Well, in this problem, we know the length, it's 40 minus 2x. And we know the width, it's 30 minus 2x. And we also know what the area should be in the end. It should be 336. So when I substitute all those values in to my formula, I'm going to get 336 equals the length, which is 40 minus 2x, times the width, which is 30 minus 2x. Okay, now I'm going to distribute here, and it's going to give me a quadratic equation, which is what we've been working with up until this point. So I have 336 equals, it's going to be 1200 minus 80x minus 60x plus 4x squared. Right, I'm distributing. All right, now combining like terms, I have 1200 minus 140x plus 4x squared. And now then I'm going to move the 336 over to the other side of my equation. So I'm subtracting 336 from it here, and that's going to give me 864. And now just rearranging it so it looks like I'm used to, that 864 is going to go to the end. And I have now 4x squared that I'm bringing down, and the negative 140x that I'm bringing down. So now here is my equation. 4x squared minus 140x plus 864 equals 0. Now I need to solve for x. I need to find the values of x. So I would use the quadratic formula. You could probably try to factor that, but those numbers are so ugly I don't want any part of that. And so again, I'm looking for x. X is the value that I cut out. So that's what I'm looking for. How much did I cut out? Well, so now I'm going to plug into the quadratic formula. X equals negative b, so that's going to be positive 140, plus or minus the square root of b, negative 140 squared, minus 4 times a times c, and this is all over 2 times a. And so now I'm going to plug all that in. So when I plugged in the first time and used the plus, I got x could be equal to 27, or, and now I'm going to have to do the minus. And now when I did the minus, I found x could also be equal to 8. Okay, so let's think about it again. This x represents how much I'm cutting out of the corner. Well, if I cut out 27 from both corners, then I'd be cutting out 27, and another 27 would mean I'm cutting out 54 centimeters. Well, that doesn't make sense because the entire side was only 40 centimeters to start with. So 27 is not a valid answer, so I'm going to throw it out. Now let's look at what if I cut out 8. Well, if I cut out 8, then this would be minus 8 minus 16. That's going to give me 24 for my length here that's in blue. And then it's going to give me 14 for the length here, right, once I cut those corners that are 8 and 8. So just to test, if I do 14 times 24, I get an area of 336, which is exactly what it's supposed to be. So this is all checking out. It's all making sense. So that means I cut out 8 centimeters squares on each side of the box. So this is 8, 8, 8, 8, and so on. And so if I cut out an 8 centimeter side here, and then I fold this part up, then that means the height of this box is going to be 8 centimeters. So again, that's a pretty challenging problem. You see all the steps you have to do. If you have any more questions on any of them, you can send me one in particular. I can work it. Hopefully this has been some help for you.